This is her 4th year in High Star. Then we have two, actually first-year High Star participants, Joshua Dasa and Haley Kushi. And these two students come from Kamehameha Schools on Big Island, actually. So please give them a warm welcome.
Okay, so our project was on Venus. Oh, yeah. Venus. And we interpret Venus as Terra's hotter twin, which is also, Terra is also Earth. So, yeah.
So the goals for this project was to find the wind speed of Venus, and we can also find the rotation rate of the Venetian atmosphere, and also to find out how long it takes a cloud of Venus to circumnavigate the planet at its equator.
Okay, so first we did a little bit of background information on the planet Venus. So although the name Venus comes from the Roman goddess of love, Venus, the planet, is depicted as many different things in different cultures. Like for example, Hawaiian, they interpret Venus as a male god. So, some more background information. Venus's lower atmosphere contains gases and particles constantly producing a greenhouse effect, also known as global warming. So we want to see if Earth will one day become like Venus because of this. The winds on Venus blow because Venus is known to be super, super windy. So this happens because the pressure difference of the atmosphere. We don't know exactly what it is because we're not at Venus, so we can't measure it right now with the technology we have. And so Venus's distance from the sun, our sun, in our solar system is 108 million kilometers. And one Venetian rotation takes 243 Earth days. So it takes like, one of their days is like 243 hours.
Okay, so as you know, Earth rotates from the west to the east. But Venus is the opposite. Its atmosphere and the planet Venus rotates from the east to the west. So you would see the sunrise on the opposite side than you would on Earth. And so in 2006, ESA, they sent a probe to Venus to observe, to get a closer look of Venus. And so the images taken, they spotted a vortex in the southern hemisphere. And so these vortexes they also look like the hurricanes we have here on Earth. As you can see, that's the vortex. And these are from two different filters also. And that's our hurricane. But the thing is Venus has this vortex constantly and it's never fading away. While Earth has hurricanes and they come and they go. So, yeah. And also, some other background information. Venus also, it's believed to have, when the planets were being formed, it was believed that Venus actually formed very rapidly compared to the way Earth did. And as the Earth started to evolve, Venus slowed down very rapidly. And so that's why we're wondering why Earth is so much more habitable while Venus isn't.
So the procedures that we did were, first we took images that we got from the Venus Express spacecraft, and we examined them, and these pictures were taken an hour apart. And so we can use these pictures to track the movement of the clouds, and we can track them by using latitude and longitude. And yeah, so the time difference between each picture is about an hour, and from the images we got the latitudinal difference, which is the distance, and also the time. And with this, we can find the rate of the objects in Venus moving. So like, yeah, the rate of the winds. The three of us measured clouds in Venus and the location, so in consecutive 1 hour intervals. And the following graphs shows what the data we collected.
So how Josh was talking about how we use images taken by the Venus Express to track the clouds on Venus. This is an animation showing the same pictures that we took. We had hard copies and we marked little dots on the clouds we wanted to track with pencil. And the lines, the grid lines on here, are the latitude and the longitude, which we use to find the distance. Yeah, that's right.
Oops, sorry. Okay, so from these 4 points are there are points from, if you can see that as the longitude increases, the time as the time increases, the longitude actually decreases. It decreases, which means that it's moving over. Yeah, that's just to show it's moving. Sorry. Okay, so the meridional component of wind. So all those points up there are basically each of our data we collected, because each of us had the same image set, and what we all did was we picked our own 10 points and tracked them over 4 different images. And so as you can see, as the latitude increases in latitude, as the latitude increases, the speed or the rate, it stays pretty constant at 0. So this is the zonal component of winds, and so if you can see, as the latitude increases, the rate, you can see that there's a slight increase also. So these are all of our graphs that we plotted, and so you can see that for the zonal components of winds, that there's a slight increase, and so since it's constantly a constant of a slight increase, then it's pretty accurate. And also for the meridional component, you can see that it kind of stays pretty constant around 0 also.
So this graph, it pretty much shows the rate that a cloud can circumnavigate Venus. So the frequency is actually how many clouds pass within a period of 4 days. So our peak is at 4 days, which means that the most amount of clouds can circumnavigate Venus in 4 days. And circumnavigate means to go around Venus.
Here are the results that we got from analyzing the data on the graphs you just saw. So it showed our images, or the data we collected from the images, show that the winds on Venus have a change in speed over the latitude, which was actually an increase. So that means the clouds on the east-west winds were getting faster as the latitude increased. So like closer to the equator, the clouds move slower. Farther from the equator, the clouds move faster because of the vortex that Gina talked about earlier.
And also, our 4 days period, it was also, it's the same time period, is the same time as the found time of Venus. It was like,
our data matched what previous researchers of Venus found. They all said that it takes the clouds of Venus about 4 days to go all the way around the planet, around the equator. And that's exactly what we got to. So we're pretty sure we researched and collected data pretty well. Never mind. Okay, so our next steps, which is like our follow-up for this project, what we want to do after High Star is finished, we want to track more clouds because we didn't have a lot of time. Like we wanted to track like more of the clouds, but we didn't have the time to track them over like more than a few hours. So that way we could get a more accurate conclusion of the whole planet rather than just a small portion. Also, we wanted to create a more accurate positioning of the clouds so that we wanted to analyze our data further to see that there's no errors in what we collected, what we saw. Yeah.
So we'd like to thank Auntie Mary, Dr. Sanjay for helping us, JD, Mr. Nasser, and all the participants and speakers of High Star, and also Heather Kalun. Thank you.